Hello friends, welcome to Suresh Aggarwal's Mathematics Shortcuts. Your one stop for learning all the mathematics short tricks which make you smarter and enable you to calculate 10 times faster, especially the methods which require smartness. That is the methods which you have to use to crack multiple choice questions where steps do not matter. And that's what is the intention of this amazing channel, to provide you tricks through which you can crack multiple choice question quant exams comfortably, whether you are at school level appearing in the Olympiad exams or college level preparing for some higher university exams or the placement exams, SSC, UPSC, CAT, MAT and whatnot. So friends, what do we have in this video? An amazing exclusive concept through which you will be able to make divisibility rules of all prime numbers up to 99. So if I ask you what is the divisibility rule of 7, you're going to struggle if you have not seen the previous videos. And what about 13? Do you know a divisibility rule of 13? Or for that matter, divisibility rule of 19? I can tell you a divisibility rule of any number up to 99, and that too not one method but two different methods for each number. So after watching this video, you will be able to check the divisibility of big numbers by two-digit prime numbers like 13, 17, 19, 23, 29, 31 and all those prime numbers up to 99. So you need to watch the complete video to learn something very useful. So what is the title of the video? We have the divisibility rules up to 99, and this is known as the oscillator method. So, I'll tell you the concept of the trick. And this happens to be from the chapter number 3 of our ebook of short tricks, which is entitled Division and Divisibility Hacks. And I hope you have seen the previous 14 different videos in which I told you all these division tricks and divisibility hacks. Now this will complete the chapter. So let's see the concept in hand. Before that, let me tell you about the ebook of short tricks, which you must be excited about, because you need to study from that if you want to be smarter, if you want to be a cut above the other students. So how to get a copy of that ebook of short tricks, which contains 24 chapters, different chapters and 350 such short methods. You need to send me a message on WhatsApp. This is the WhatsApp number 9896369963. The details, you can see the details in the description of this video as well. So friends, let's understand what is the concept behind this trick, how to frame divisibility rules, how to be an inventor, and you need to do it yourself after watching the video. So the concept used in the trick. So let me take up a very simple example of making a rule for which number should I take? Let's go for 13, because you don't find divisibility rule of 13 in books, right? So what do you do with this number 13? Now if I want to check whether a 5-digit, 6-digit or a 10-digit number is divisible by 13 or not, the first thing I should know is the oscillator for 13. Now oscillator is a number. It can be positive or negative. So if you know 13 times table, or you can do some basic multiplication, you need to multiply this by a single digit number so that your answer ends in either 9 or your answer ends in 1. These are the two numbers, and the end numbers, the unit digits of the product. And you have to multiply 13 by a single digit number only. And invariably, all tables of prime numbers beyond 10, they will contain a number ending in 9 and a number ending in 1. They have to. Okay. So we all know 13 3 times is 39 and 13 7 times is 91. Right. So we have a 39 and a 91 in the 13 times table. So this is the first thing we should know. We are framing two different rules, and that is why I told you both. But even if you know 39, you will frame one rule yourself. So I want to convert this number 39 to a perfect number of tens. That is why I took number ending in 9 or ending in 1, because they are easier to convert in terms of tens. 39 plus 1 gets me 40 and 91 minus 1 gets me 90. Perfect number of tens. So how many tens are there here? 4 tens, right? And what did I do? I added 1, so plus 4. How many tens are there here? It is 9 tens. And what did I do? I subtracted 1, so minus 9. Now these two numbers, plus 4 and minus 9, they are the oscillators for the divisor 13. Now for every divisor, like this is the divisor 13 here, we have two oscillators and therefore two different rules. So what am I going to do with these oscillators? I'll use them to test the divisibility of any number by 13. So let me take an example where the number is divisible by 13. Suppose I take the example 5941 and I need to check whether 5941 is divisible by 13 or not. So what do? I know that the oscillator for the divisor 13, the smaller oscillator, I'll take plus 4. I can take minus 9 also, but I'll use plus 4. Easier, right? So what will I do? I will separate out the last digit, write the remaining number 594, and because oscillator is plus 4, I will do plus 4 times the unit digit, 4. So this gives me 598. I'll do it one more time because 598 is again a difficult number. So 59 plus 4, so plus 4 times this, 4 times 8, 32, which gets me what? 91. And I know that 91 is divisible by 13, but if you still don't know it, you can do it one more time. 9 plus 4 times the unit digit, 4 times 1 is 4, gets you a 13. And suddenly I have a 13 which is divisible by 13. So at the end, when you get a number which is divisible by 13 or you get a 0, then the entire number is divisible by 13. So that is the use of this oscillator plus 4. I can do the same thing on 5941 using the oscillator as minus 9. That means 594 minus 9 times the unit digit, and still the method will work, and therefore I have two different rules for every prime number divisibility, right? So I hope you have understood this. If you have not understood this concept, replay the video, watch it 2 times, 3 times, try it yourself, and then see the remaining part of the video. Here we go. Let's check the divisibility by 23 for this number 68652. So I need to check whether it is divisible by 23 or not. Knowing 23 times table, I think we are joking, right? Nobody knows 23 times table, and therefore it can be difficult. But what is the oscillator for 23? So I am not bothered about the big oscillator. I'll look for the small oscillator. Now 23 1 times 23 ends in 3. 23 2 times 46 ends in 6. 23 3 times, I don't have to go beyond 3, see. 23 3 times is 69 and that ends in 9. So when I add 1 to 69, I get 70. 70 means 7 tenths. And what did I do? I added 1. So plus 7. Now this is the oscillator for 23, and you can actually do that mentally, right? 23 3 times is 69, so it makes 70, so plus 7, that is the oscillator. So what do I do with plus 7? This number 6865, separate out the last digit, write the remaining number 6865, and because the oscillator is plus 7, I will do plus 7 times this 14. So this becomes 68 and then 79. Again separate out the last digit, 687 plus 7 nines are 63. So we have 7 plus 3 10 0 1 carry, 7 plus 8 15 5 1 carry, and then 7 750. If you get a 0 at the end, forget this, and immediately I know that 23 doesn't divide 75, and so the answer is a big no. That means the number 68652 is not divisible by 23. Or still, if you struggle with 75 also, you can do it one more time, the same step which we are doing, and that will simplify the number. Let's check the divisibility of this big number 598559 by 41. So whenever the number ends in 1, it's a very easy oscillator. 41, 1 times is 41 only, and when I subtract 1 from this, I get 40. How many tens are there? 4 tens, and I subtracted 1, so minus 4. Now this is the oscillator for 41. What is the oscillator for 71? Minus 7. What is the oscillator for 61? Minus 6. And that's easy, no? Right? So 5, 9, 8, 5, 5, and last digit separated. Now 5, 9, 8, 5, 5, minus 4. So minus 4 times 9, 36. This will give me the first difference. And how much is that? 5, 9, 8 remains as such. 55 minus 36 is 19. So we get a 19. Separate out the last digit again. 5, 9, 8, 1. Minus 4. So minus 4 times 9, 36. And I will get 59 followed by 81 minus 36. So I should be able to do that orally, but in case I struggle, I can use the rough column. For 45, so I write a 45 here. Separate out the last digit. 594 minus 4 times 5 is 20. So 574. One more time. Separate out the last digit. 57 minus 4 times 4, 16. And that gives me 41. And 41 obviously is divisible by 41, right? Because it comes in the table of 41, and therefore the entire number this is, yes, it is divisible by 41. See, I tested the divisibility of a 6-digit number by 41 using the oscillator minus 4. Okay, let's see one more question. Check divisibility by 79, and it's a big number. So 79, as soon as I see a number ending in 9, my number of steps are reduced, because times 1 is going to give me the same number, and when I add 1 to this, I get 80. How many tens are there? 8 tens, and I added 1, so plus 8, right? So plus 8 is the oscillator. Let's pick up the number 8, 7, 6, 5, 0, /5. Separate out the last digit here. What do I do? 8, 7, 6, 5, 0 plus 8, right? So plus 8 times this is 40, and that gives me a 0 and then a 9, and then 876 retains its place. Now the 0, it doesn't matter if it comes in at the end of the number, so I'll separate out like this. So 8, 7, 6 plus 8 times 9 is 72, so I'll have to add them. So I get a 8, 7, 7, 14, 4, 1 carry, and then 9. Separate out the last digit. 94 plus 8 times 8 is 64. What do I get? 158. One more time. 15 plus again 8. So 8 times 8 is 64. So I get a 79. And 79 is the number here. So 79 divides 79. Pretty obvious. And therefore the complete number is divisible by 79. So the answer is a big yes. And you can see how quickly I found out the oscillator, and then I started separating out the last digit and performing these operations to check the divisibility by 79. There is one more oscillator for 79. Do let me know in the comments all the second oscillators for the numbers which I took up in these videos, and I'm sure you are going to rock. And up to 99, the divisibility will not be a problem for you. So friends, if you like all these videos which I have been posting, do subscribe the channel Suresh Aggarwal's Mathematics Shortcuts, and don't forget to give it a share. It always helps the educators if you post the channel link in your WhatsApp groups, so that they can also watch the wonder of mathematics. And along with the subscribe button, you need to hit the bell icon. This is the bell icon with subscribe button, and when you click this, you get the option of all notifications. When you click that, you will start getting the notifications of the future uploads on your mobile itself. So friends, do practice this method and let me know, did you find it exclusive? All the best.